Hello. Yeah, I think it's okay. Okay, let's talk about user tracking over TLS session resumption. Let me first answer the question, what is TLS session resumption? That is when a connection, the cost of a TLS connection is compensated over multiple connections. That a new connection is conducted by exchanging an identifier, which is, and then both peers, they resume the previous symmetric key, and those gain temporal and computational performance gains. However, this leads always to a situation that a server can identify the client through the secret key. Thus, in my presentation now, the attacker is the server who is taking part in the TLS connection. TLS session resumption is very widely used on the internet. My measurements show that 96% of the TLS-enabled Alexa Top Million sites support session resumption. And Cloudflare or Google report that approximately half of all the new connections are established through TLS session resumption. So, what are the opportunities and limitations of tracking someone over TLS session resumptions? The opportunities compared to HTTP cookies or browser fingerprinting are that you get a much faster unique identification of a user. This might be especially relevant in scenarios like real-time online biddings, where the more time you spend on identifying a user, the less time you can spend on the bidding process itself. Furthermore, from an economical perspective, you have a lower consumption of bandwidth and computational resources on both sides, which is also attractive to the tracker, because you don't have to issue an additional request for the HTTP cookie or to send the browser fingerprinting script to the client. Limitations are, beside the obvious limitation that this tracking mechanism applies only for TLS connections, is that a browser restart terminates a tracking period. Thus, we need to investigate what is the actual uptime of a browser. And the tracking period is terminated because the TLS cache gets cleared within the browser restart. Furthermore, browsers apply countermeasures against this tracking mechanism, such as the Tor browser, which completely disabled session resumption. However, this also leads to performance reductions. Thus, in my evaluation, I investigate of 48 browsers the session resumption lifetime, and also how feasible it is to conduct third-party tracking with those browsers. Those first have a look at the browser restarts. I access publicly available data of the Mozilla Foundation for their desktop and browser, desktop and mobile browsers, and analyzed crash reports, 500,000 each. And this cumulative density function shows that the browser uptime usually, or for the majority of users, exceeds more than a single day. And that also the tracking period is over a single day. However, this is a very indirect measurement. Those take it with a grain of salt. And we see quite a lot of browsers which have an uptime of several days or even several weeks. My experiments to test the browser default configuration. There, as I already explained, I investigated 48 browsers and investigated the session resumption lifetime, which is like the maximum delay between 2 visits of a website where the browser still tries to establish the new connection over a session resumption mechanism. Furthermore, I investigated the feasibility of third-party tracking, like you can see in that figure. I first requested a website A, which included a third party, the third-party tracker. Then I waited till the connections timed out, and then I requested a website B and observed how the browser established the new connection to the third-party T, whether the browser applies TLS session resumption or whether the browser applies completely or a full new handshake, which does not allow to track the user. Here's a summary of my results for the most popular browsers. You see that Firefox and Safari allow tracking periods of 24 hours. And you see furthermore that third-party tracking is viable across the majority of browsers. Within the evaluation of all 48 browsers, only 6 browsers did not allow third-party tracking. Microsoft Edge is a real exception in this data set, which is caused through the sandboxing mechanisms. The question arises, is this tracking period now limited to 1 hour for Chrome and 24 hours for Firefox? I would say no. Because here you see a successful TLS 1.3 resumption handshake, and you see the PSK, the pre-shared key, and that is a session resumption mechanism used in this case. And you see that the client provides this identifier to the user, and after the handshake, the server provides a new PSK, a new identifier to the user, which the user will use in a future connection. And there it's not specified in the TLS specification. And also during our test we noticed that a lot of browsers are making a mistake and they reset the lifetime of that PSK. Thus, this allows to extend the tracking period. Thus, how do we evaluate this prolongation attack? I had the chance of using a DNS traffic log, which included more than 3,800 users over a 60-day period, and these data were pseudonymized. And then I tried to find out which tracking periods are feasible from a server perspective. By observing, okay, when the user returns within a time period which is smaller than a given session resumption lifetime, how long does this tracking period become in a real-time, in a real-world scenario? Another evaluation I conducted is to estimate the share of permanently trackable user. That means the share of the user within my data set, which can be identified throughout this 60-day period based on the TLS, or based on this prolongation attack. Here you see a plot about the feasible tracking periods for the median user within our data set. And you note that there's approximately a factor of 10 between the session resumption lifetime and the maximum tracking period. Furthermore, you note that when the session resumption lifetime exceeds 6 to 7 hours, then the maximum tracking period increases rather fast for longer session resumption lifetimes. Thus, it seems like this is a period for which users, like the night rest of a user, and when the session resumption exceeds this night rest, then we are going fast into a multiple day maximum tracking period, which is not plotted here, but given in the detailed values. For a session resumption lifetime of 24 hours, we get already 8 days of a tracking period. And for a session resumption lifetime of 48 hours, already 12 days tracking period. Thus, let's have a look on the permanently trackable user. We see that for a session resumption lifetime of a single day, there's only 1% of the users permanently trackable. However, when we increase the session resumption lifetime to 7 days, and please note that the TLS specification of TLS version 1.3 recommends as an upper limit a session resumption lifetime of 7 days, we can permanently observe 65% of all users through this mechanism. Thus, I want to propose some countermeasures. The simplest countermeasure, as done through the Tor browser, is to deactivate session resumption. However, this has an impact on the performance. Thus, I propose the browser vendors should disable third-party tracking through sandboxing, like Microsoft Edge is doing it. Furthermore, they should reduce the TLS session resumption lifetime to a single page visit, which is approximately 10 minutes, or at most 6 hours. They should prevent a reset of the session resumption lifetime, thus that they prevent the prolongation attack. I would like to see that the TLS working group recommends a reduction of the upper lifetime limit in the draft of TLS 1.3. And I think it makes sense to recommend a measure to prevent a reset of the TLS session resumption time. There exist also countermeasures which do not rely on TLS session resumption to achieve zero round-trip time handshakes, especially semi-static Diffie-Hellman key establishment, such as proposed in OP TLS 1.3, or the recent draft Rescola TLS 1.3 semi-static Diffie-Hellman. They are going into that direction. However, if we want to apply these approaches, then we need to make sure that the public key is shared within an anonymity group. The conclusion is TLS session resumption is a realistic tracking mechanism which is widely supported and allows unique user identification with a very low bandwidth, computation and temporal overhead. And browser vendors and the TLS working group need to further restrict this privacy problem. Countermeasures are available, but they lead to a performance reduction. Thus, I thank you very much. And if you want to have a look at the slides, they are available there. And I also have a preprint article, which I can share per mail.
Thank you. Okay, so we've got one microphone, and I'm going to share it with Tarek. And we've got one question here.
So you say the countermeasures impact performance, but like how bad is it? Basically, how much typical session is slowed if you for different for different of these countermeasures?
Okay. I have a backup slide on this. Like, if you choose different session resumption lifetimes, what is the impact in regard of performance? If we assume a session resumption lifetime of 5%, then 17.7% of the users, they still can conduct session resumption because the revisits occur sometimes very shortly after the initial visit. And there is not much benefit in choosing a TLS session resumption lifetime beyond 24 hours. Beyond 24 hours to 48 hours, you only get around about 6% increase in users. And does it answer the question? Or?
I mean, if you take just one session, what's the difference between having this, having this performance gain versus not having it if you have to regenerate a key? Like, if it's so this is good information because it indicates how often the thing is useful, but the question was also like, how useful is one single event, right?
Yeah, and I think the factor might be 100 to 1,000 or something like the symmetric key establishment compared to a full handshake.
Hi, on slide 11, could you open it again? The last line reads public key is shared within an anonymity group. What does it mean?
That is these proposals, or like we also spoke about the recently published SNI encryption. There is a public key available, and you encrypt the first message with this public key. But if every user gets individual public key, then you can track these users based on these public keys. However, like it's currently done with Quick, like Google's Quick protocol, they use a public key, and this is shared within a large anonymity group, and you can use this public key, and cannot be identified so easily.
Hi, question from the internet. TTL asks, does TLS 1.3's zero RTT reduce the negative impact of disabling TLS session resumption?
Can you repeat it, please, once?
So does TLS 1.3's zero RTT reduce the negative impact of disabling TLS session resumption?
The new TLS will have the ability to much more quickly do a TLS
Yeah,
handshake, and therefore maybe disabling resumption is fine and safer and good enough.
But we checked for a couple of browsers the private mode, and that didn't change anything.
Please, if you find a link between, if you find a way to link private mode and non-private mode, like most browsers are going to know that this is a serious bug.
Yeah, I think we can easily check whether they clear the TLS cache when they move to private mode. Thanks.
We are without a microphone and without, Tarek was saying that he smells something burning up here. Stay calm. So if you are good at yelling your question, we can continue to yell out questions. And then after that, we'll take a break where we do some technical fixes. Thank you for the microphone. Who wants to? So to follow up on the Firefox thing, I was talking to the Tor browser people last night, and they say that the new Firefox has an isolation approach that they are putting in now. And I guess this is tied to the broader tracking resistance goals that Firefox has. So it might be, I haven't looked at what they do, it might be that they have some smart idea.
Google Chrome with the version 68, they also announced that they want to enforce stricter sandboxing, but I have not checked that yet.
Anybody else have a thing they want to add about either TLS tracking with session resumption or browser tracking in general? It sounds like we might move to the technical fixes side of the session. Thank you.